Hello, everyone. Good to have you here. I have Noor with me. Very good to have Noor here. Noor is one of the co-founders of PyCAD, and Noor, I think, correct me if I'm wrong, Noor. I think you have done your master's in computer vision. You're worked as a research engineer. I loved the way you have built the course in Udemy. I think with TensorFlow, if I'm
Yeah,
not
that was a long time ago.
around more than 3,000 students, right?
Yeah, yeah, yeah.
That's awesome. I
Thanks,
mean,
thanks.
I didn't know that you had an educator. I think you told me, but yeah, I was so amused to see that. And then you have started building PyCAD. Um,
True.
so very excited to have you here. Okay, a lot of
Thank you,
things
thank
for
you.
me to
Happy
learn
to be
from
here.
you,
Yeah.
and I'm sure the viewers have a lot of things to learn from you too. So let's just start it. So we have discussed on. You are the first person to be on Chintan for podcast. So congratulations for that.
Thank you.
Uh,
You don't have like other episodes or like
yeah. So as I have said, I have done it in other channels, not like for Chintan.
yeah, the channel. Okay, channel.
Yes,
That's
yes,
the
yes.
difference. Yeah.
So as we have discussed, we will have a few questions, and I will show the questions one by one, and we will discuss a bit, and we can go into different tangential directions. We will try to keep it within 1 to 1.5 hours at most, not more
Sure.
than that. Okay.
Okay.
So
Okay.
I want to really go into your background and your journey into medical imaging AI because I think you have a background in OCR, right?
Yeah.
Uh, and
Uh,
yeah, so let me so essentially your background is in OCR and I think also in industrial automation. So how did you move into medical imaging AI?
yeah, that's well, thanks again for having me in your podcast. So the my background is actually, or my studies were in computer vision. Like it's the general field for all of these things, industrial automation or OCR or medical imaging. So like the backbone is computer vision. So I did my master's in computer vision, and there we had some courses about AI. Although there we didn't do anything in deep learning. It was mostly like SVM and like logistic regression, linear regression. People who studied machine learning, they know about these like the basic algorithms for machine learning. And then I remember I wanted to explore AI more, but at that stage I didn't know what I want, like because computer vision was so big. And I said, you know what, I'm gonna try to experiment with a few different places where we can apply computer vision, and then decide later which direction is best for me. So I started with industrial visual inspection, which is like an automation phase in multiple industries, because that's where I did my internship in a company that was doing this, my master's internship, and then they offered me a position, so I started with them. I spent like almost 2 years with them. Then I had an opportunity. Of course, there were some opportunities in the middle that were small. I don't want to go into them. But then I went to a company that was doing document imaging. So that's like a different type of different field of or subfield of computer vision. So I did OCR with them, like how do we apply CNNs, LSTMs to solve like that. This was before all of the like the hype behind ChatGPT and all of these large language models and the vision language models. So we would build like small neural networks that would take a patch of text, and we train it to recognize that text. There was so many small use cases where we did this, so that's where what I did after that. And then I had an opportunity with a company. Both of these companies were in France, the ones that I just described. Then I had an opportunity to work with a company as a consultant with a company in the US, and they were doing medical imaging. So the opportunity seemed interesting. Like the first use case was this something that I never even thought of doing before. So like we started with the use case in dentistry, and very specific use case in dentistry, which was about analyzing bite wing images. So and
What is
then
this?
this bite wing images. So biting X-rays. So like that's where
Okay,
you
okay.
go to a dentist and they give you something to bite. Then they take a scan of only specific region of the mouth. So
So that was the first medical imaging thing you have done, like project, big project.
professionally,
Okay, okay,
yes, yeah. Like before that, I might have like played a little bit with
got it.
some use cases, but the first use case professionally that it was this, like tooth numbering specifically, and
I have a
then
question.
yeah.
So, so when you moved from that OCR to medical imaging, like, were they happy with your old OCR projects and they just directly took into medical imaging, or do you have to like go through some?
The reality is, I was waiting for an opportunity to leave that that company. To
Okay,
be
okay,
completely transparent, it wasn't the case for the first company, the one that where I was doing industrial visual automation. I really liked that company. I liked the work. I liked the product that we were building. I like the team, everything. It's just that I wanted to explore some other things because that was my plan in the beginning. But for this second company, I was just looking once I got like a nice opportunity, I left. So I started with this company that we were doing this project, and then they had so many more projects, both in 2D medical imaging and 3D. So like 2D, I'm talking about X-rays. 3D, I'm talking about mostly CBCTs, cone beam CTs, and like how to look at multiple slices in the scan and then build algorithms for segmenting different regions. So we started with one thing and then we started doing many more things, and that's when I realized, okay, there are lots of opportunities here, and also I realized one thing, which is whatever we end up doing in the medical domain, like as an engineer, whatever I end up building, at the end of the day is gonna impact one of the most vulnerable segment of society, which are like people who are sick. And I said, I think that's something that I want to get more involved with. Like the other parts, you do OCR or you do industrial visual inspection. It's nice. There is some impact, but not like an impact that you do in the medical field. So that's how
Which
I
year
got
it
into
was,
it.
Noor? Which
Sorry?
year it was?
This was 3 years ago. So this was in 2022. I started this medical project.
Okay, okay, okay. Um,
Mhm.
so you worked on this with a company or a person?
Yes, yes.
Okay, okay, okay. Three
That's
years
how
ago.
we
That's around
started.
2022. So
Yeah,
okay. So I'm writing down this timeline because I have some questions for you based on the timelines of the different models. So
yeah,
that's why.
yeah.
So you
Sure.
were using UNET back then?
No, I think the first model we tried was like mask RCNN, 3D mask RCNN.
Okay, okay.
But that's like for instance segmentation, because we didn't just want the semantic segmentation, we wanted the instance segmentation part as well.
Perfect. So we have got this question really well. Happy to know your journey. But what was this moment that you wanted to build your own stuff? I know at the end of 2023, I guess. I think you started PyCAD at 2023, I guess, if I'm not wrong.
Uh, yeah, so that's look. PyCAD went through several phases. Like the first version of PyCAD was created by my brother, which is like a blogging
Yeah.
site. He was working on several projects, and he was just putting stuff on the website. That's how it started. This was like maybe 6 years ago. I can't even
Oh.
remember. Yeah, so it was like a mix of everything, and then like okay, I'm not gonna be answering this exact
So
question
let
on the
me
screen, but
introduce,
like yeah.
like tell the audience about your brother's name, Mohammed. So I
Yeah,
will be doing a podcast with him after doing this podcast in later date. So yeah,
yeah,
please, sorry to just
yeah. So you can ask him about all of the like the starting point of PyCat. So like it started like that, and then my brother was posting some blogs there. I had my own website with my own blog in it, and then what we noticed that some of the blogs that he was putting, which were about medical imaging, because again, there were so many blogs that he had put on the site. There were like stuff regarding Arduino, like electrical circuits,
robotics.
Yeah, some related to like even I think visa process for Algerians to go to France. It was like a mix of
Mix up
of
one.
everything. Yeah, but when we were looking at the ranking of the pages, like where the people were basically looking in the site, we saw that the top pages were related to the blogs that are in the medical field, like Monai, like the different formats in medical imaging. So like that at least gave us the first hints of, okay, there is people are looking for solutions
So
in
which
this
year it
space.
was approximately?
So this was, I would say, maybe 4 years ago. Yeah, I think maybe 4 years ago, because like 3 years ago, I started with the first client who wasn't like, we didn't have PyCAD, but we started as a contractor with this client. Later on, he became a client of PyCAD. But before that, like you can say a year before that, maybe we had started to notice all of these things. And moreover, I had I put a free course online. I submitted it to Free Code Camp, the YouTube channel.
Yeah,
It
yeah,
was
yeah.
about TensorFlow. And then my brother submitted his course about Monai. And then what we realized is that there was lots of interest for Monai, for the Monai course, which was a free one. And actually, funny enough, this client, which is now a client, but at that time he hired us as contractors. She, like the CEO of the company, she saw this video of my brother on YouTube, and she reached out to him. So he started working with her, and then a month or a month and a half later, I started working with them as well. So that's
Oh, that's great.
yeah, that's how
So this is
it
a
all.
medical company.
Yes, medical company. Yeah.
Okay, that's great. So so people before people get confused, I would like you to explain the name PyCAD and what is Pi and what is CAD means in medical imaging. So please explain.
Uh, Look, I can give like an answer, but I would prefer that my brother answers this, because,
Okay.
as I said, PyCAD started before the medical, like before we focus on this. So
Okay.
it doesn't mean what most people think. Like it's not Python then CAD, like the CAD models. It's not like that at all.
Oh
Like,
wow. Seriously, I thought
yeah,
it was Python plus CAD.
I know. That's what most people think, but it's not like that. It's actually like Pi really means Python, but the other letters I'll let my brother explain them because they meant completely different thing at that time. But we stick with the name because it's just like we had the pages ranking and all of that. We didn't want to change that.
Hmm. The name falls into place actually. Like yeah.
Yeah. I mean, at the end, yeah, you can say that. Yeah.
Yeah. So this is something I should ask Mohammed. Let me
Yes.
write it down.
This way, also the people are gonna go to that to his
Yeah.
episode to watch it.
Perfect. Thank you so much. So, okay, so this was like you had a client, you started working on it, and that was like that's aha moment, like this is something we need to do. And then you started like focusing on building PyCAD as a startup to be like
Yeah, yeah, and not just that. Actually, like, so there were like many different things, but here I'm just like, maybe I can't remember all of them, but I remember a few of them. For example, one thing which is maybe you faced as well because you worked in the field, which is when you go to computer vision that deals with the natural images, like the normal RBG images, you're gonna find so many resources. You're gonna find so many tutorials. You're gonna find so many people doing it. It's just because it's like those are natural images. You find them everywhere. But when it comes to specific, like even industrial images, like I was using the industrial cameras to capture some stuff when I was working in that first company. Even that, it's still at least the cameras that I was using, they were high resolution, but they were like still RGBs, not like a different format. But in the medical field, it's like a completely different format. You have all of these new formats, and when you try to search for resources, it's not easy to find for specific like specific tutorials on how to do things. You have to spend time. So, and the fact that what started to happen is that once we started to focus on medical field, we started to put more blogs. We started to even like maybe if you go back those like 3 years ago, maybe, I was still posting mostly computer vision. Like if you go to my LinkedIn, you go back 3 years ago, you'll find me posting a lot about just computer vision, general computer vision content. But when we started to focus a little bit more on the medical imaging side, we started to get DMs from people asking us, can you help us with this, like with this task? We were looking for someone to build a pipeline for us here. And at that time, because we didn't have PyCAD yet at that time, we were mostly declining. We were saying like, no, we're already working like as contractors. We didn't have like a, we didn't think of this as a business, like let's start something to help clients. But because we started to get more and more requests, and because we liked the field, we said, okay, maybe we can actually turn this into a business, like the agency part. Because before that, we had, both me and my brother, we had tried to do stuff by ourselves, and this was actually the first venture, you can say, where both me and my brother, we collaborated on the same thing. Before that, each one of us was trying to build his own thing, and building like a product, but we didn't succeed.
That's great. That's great. So good to hear it.
Yeah.
So you meant, when you said medical imaging, you like different types. You meant DICOM, Nifty, like this, or something.
Yes.
Okay.
Yes. Exactly. Yeah. So like that, you can say, we can talk about the file format, which is like DICOM, Nifty, NRRD, or STLs, PLYs, all of these. Or we can talk about the modalities as well. Like you have MRI, you have CT, you have CBCT, you have PET, you have a ton of modalities as well. So
Okay.
that was
I
also
will come
like,
to those questions.
yeah.
So, okay, I think your journey is very clear now. Like now, I think, yeah, I think, can you? I think, yeah. So, can you share an early failure that set you back, right? But it seems like you started from success. Like your failure was building initially. Like, is there any failure in PyCAD initially while building it as like an agency when you started thinking about it as a business?
Look, in terms of like doing the company, like incorporating the company, doing the company registration, all of this, you can say it's still recent. Like this is, we're talking about maybe a year, a little bit over a year ago. So like really starting the business. Before that, as I said, both my brother and I, we tried different things and we failed miserably. Now at PyCAD, I can't say that we're succeeding in the level that we want. So it's still like, because we are engineers by trade. Like that's what people should understand about us. Like we are engineers, and then when an engineer tries to do business, uh, several months or maybe even years, hopefully we're not going to spend years, but several months in the beginning, you're still trying to basically understand that business is not exactly as engineering. Engineering, you have like the specific technical problem that you're trying to solve, and you spend like spend your time just analyzing the problem and all of that. But in business, what you even have to start thinking about things differently. Like in business, you have to deal with people. So when you like some of the first things, we were talking to people, and the people who DM'd us, like, can you help us build this? And we thought, okay, so there's a market here. And then we came back to them and told them, okay, we can help you build some. We thought like this is gonna go well immediately. We're gonna ask them, tell them, okay, we can do that for you. They're gonna come, but most of them did not come. Like at first, thank God we had that like contract. The client who was we were working with them as contractors, and then they accepted to become a client. But the new ones, that we tried to bring, it wasn't easy. Like I would say, we had several failures before we had like someone who accepts to work with us, and because we were unknown, and you have to basically prove that you can do the work, all of those things. Now it's getting easier, and it's even like mentally we understand it. Like now I would have 10 calls with 10 different leads and maybe close one, and I accept it because now I understand it. But before, when I was, like I would speak with 1, 2, 3, 4, 5 different leads and not be able to close anyone. I'd feel depressed, like, oh, like the business is not going anywhere. But after some time, you start to understand that actually things are different in business. You can put some metrics, you can but it's not like an engineering problem. It's a business problem. You have people to deal with. Someone is going to tell you, okay, let's start the project now. Then you tell them, okay, let's do it. Then they say, no, we don't have the budget right now, please wait a couple of months. It's like there are a variety of ways that that you can fail.
Yeah, I mean, yeah, absolutely. Like,
Yeah,
can't agree more. So many people have rejected me for podcast before you accepted me. So
really.
yeah.
I'm
So
glad. I'm glad I'm the guy
yeah,
who made you maybe not quit. I don't know, like after me, if I said no as well, how many people would it take for you to quit?
yeah. So thank you for that. Yeah, I mean,
No,
this is
no,
so
that's,
true,
that's
and
yeah,
thank you for sharing your. I totally agree with you. I think let's go on to the technical part slowly,
sure.
step by step. So we have understood your journey. Now we really want to understand and pick your mind about building and deploying the medical imaging AI solutions.
Yes.
So I think you have talked about DICOM, Nifty, NRR, I'm not sure, and also the different
Right.
modalities. So, what are the
Yes.
tools you use mostly for your entire work? What are the tools you
Yes.
use?
So there, if we split the project cycle into first you have the data handling, data validation, and then you have the building of the pipeline, the AI pipeline, and then you have in that pipeline you have like training the model, iterating all over it, evaluating the model, then doing the deployment, and you can say also integration. Like maybe we can split those two. So in terms of data validation, we use a lot 3D Slicer, and we use ITK Snap. These are open or at least free softwares. 3D Slicer is open source. ITK Snap, I'm not sure. I think maybe it's also open source.
Yep.
So we use these to basically check the data. Like when a client comes to us and maybe they send us a sample of the data, and then they want, okay, can you tell us whether we can do this or that? So the first thing we do is obviously open that scan into the slice or a TK snap, going through the slices. If they also provide an annotation file, we would open it and we would see how the annotation is being done. All of these like inspections, you can say, before we even start. And sometimes we don't even start the project until we validate this. Like we don't just tell especially when it involves training a model, we don't just tell the client, okay, just give us the data and we'll take care of it. We would say, send us some samples, we're gonna look at it, and then we're gonna give you we're gonna give you our decision whether this is good enough to move forward or not. Like I just honestly, just like 2 weeks or 3 weeks ago, we had this prospect. He came to us. He said, "Okay, I want you to build for me this," and he had like this big project. But the first step was training a model for specific use case. And then when we looked at the data, we told them, this doesn't look correct. And then we had like a call with them, and then we asked them in the call, and they weren't sure. Then we told them, okay, can you record a video when you have time and just show us like this segmentation that is shown here, explain to us what it represents. And then they did that. When they came back to us, they said, you know what, we realized actually the data is not the annotation is not correct. So we said, okay, let's put a pause on this. Let's not move forward until we get good data, and that's how we move forward. So this is like very, very important step, because if you build a model that is not performing well because the data is bad, then it's your fault. Like it's our fault. We didn't expect things in the beginning, and then the client is not gonna know that, and they're gonna say, why are the results not good enough? And you have to explain to them that actually data is bad. So these are the first tools that we use. Then we move to actually like
I have a question.
in yeah.
So, do you only work mostly on segmentation, or do you also work on other stuff?
Segmentation is, I would say, the top request. Like it's not by choice. It's like that's what everyone is requesting. It's just that which anatomical structure, which pathologies. Then you have like some problems, although they seem like a segmentation problem, but they I would say they have like two problems that you need to solve. For example,
Multitask.
tooth number. Yeah, like tooth numbering, which I mentioned, or vertebra numbering. Like in the spine, if I tell you you need to segment the spine and each vertebra you need to give me its class, then it seems like just a segmentation problem. Okay, just segment them. But if the model starts to make mistakes, maybe between two consecutive vertebrae, maybe it's going to change the classes. So in the spine, it's more or less easy because most people are going to have the same number of vertebrae. But if you go to the teeth, a lot of people, like, they have missing teeth. They could have like teeth that are on top of each other. So if you try to number them, you have the scan, you do the segmentation, but then you have a sequencing problem that you need to solve. So that's like, you can do several things to solve it, but it looks like a segmentation problem, but there are two problems in that use case. So yeah, segmentation is like the top requested basically feature that everyone is asking for it, because it's just usually it's step zero for what comes next. And I can go into details about that, but for now maybe I can just continue talking about the different tools that we use. So this is like 3D Slicer, ITK Snap. We haven't started coding yet. When we start coding, usually we use Simple ITK. It's a tool, it's a library we use a lot, which allows us to load all sorts of medical data. You can read DICOMs, you can read NIFTs, you can read NRRDs, you can read so many different formats with this library, which is like, it's called Simple ITK because it's a simpler version than ITK, because there's also ITK, which is a bigger library. But Simple ITK, they basically chose some of the most important modules especially for medical imaging, and they put them in this nice library. So that's what we use, for example, for reading the data, processing it. Simple ITK. Now for building the AI models, PyTorch is our go-to. Although for several years I was like, Go, TensorFlow, no PyTorch. But like after a couple of years, like when I did industrial visual inspection and OCR, I was mostly working with TensorFlow. I didn't work with PyTorch. But later on, I started to realize, okay, PyTorch gives you a lot more flexibility. Maybe it has some drawbacks in terms of deployment compared to TensorFlow, but overall, it's easier to build the neural networks, easier to inspect it. And moreover, I think even in terms of like the open source models that are being put out there, I think PyTorch wins by a large margin. Like even the big companies are just using a PyTorch. So that's for building the model. For evaluation, there are some either libraries that are based on PyTorch or something like that, but usually it's or like NumPy based libraries, so that you do the evaluation. Then comes the deployment. Now the deployment, of course, is gonna depend on what the client wants, like where do they want that deployment. A lot of our clients request the cloud. Like you have AWS, you have GCP. At least these two we work a lot on. Usually we use Fast API and Docker to create like REST APIs where you can put the model and you can basically send requests to that API and get responses. Yeah, so these are, I would say, the top tools.
So you said about APIs, Docker and
Fast API, a library called Fast API. Yeah.
Okay, and Docker.
And Docker, yeah. So like these are I would say the core tools we use to build, because usually the model has to be behind an API, so that you can control requests, you can keep a server running.
You can transform a PTH file into an API.
Yeah, I wouldn't say transform in that sense, but you can wrap the model inside an API. So like you have the PyTorch model. You have your inference code, let's say, which is more general. Like you have inference code that can take an input, do pre-process, inference, post-process. So this is like the usually this is where the machine learning engineer or the data scientist, this is where they work a lot. And then what we do is you build an API that could be a REST API, so you can send requests and get responses back. And this REST API behind the scene is calling your model. It's just that you're organizing how you're calling the model. Because think of it, if you are going to deploy something in production or even in a small product, you need the way to be able to call it each time. And if you just have the inference code, this means that for every time you need to make an inference, you have to maybe load the model again, and like you don't have a structured way to call the model. You have to, like, even the inputs, how would you structure them? Like, do you add stuff in your scripts that maybe download from S3? Like, it's without an API, it's just gonna be painful to serve your model. But like fast API allows you to like have an API, you just send a request to it, and behind the scene is calling your inference code.
So how is this different from building Streamlit or a Gradio based app?
Well, here I'm talking about APIs. Gradio or Streamlit are mostly to build like a user interface to use your model, but the API is more general than this. The API is like you can have an API, and then you have Gradio app that calls it, and you have another Streamlit app for someone else that calls the same API, and then maybe you have like developers who integrate your API with their own different third-party software. So like the API is more general than this. Gradio, Streamlit are mostly for building user interface.
So you have this big, let's say, Llama or DeepSeek model, okay, and
Mhm.
you download it, and then you wrap it inside an API, and then you build your own app. That's how you do it.
Yes, yeah. I mean that's to be completely fair, for LLMs, we haven't like we've been mostly using the APIs that are provided, like so that we pay only for the usage, because these are huge models, and if you serve them or if you host them on the cloud or on your local servers, either you need, first of all, you need very good servers, and second, you're gonna be paying a hefty sum. So far, we we didn't need to do that for these LLMs. But here, where I'm speaking about are, for example, UNet, MaskRCNN, YOLO models, all of these models that are focused on the imaging part alone. All of these, you take the inference code, you wrap it in an API, you host the API somewhere else, and then you call it.
So where do you host it?
Yeah, so I gave two examples of cloud providers, which is AWS or GCP.
Hmm. Yeah.
So both of them, they have different services to host the API. So for example, on AWS, you can either rent an EC2 instance, which is like a virtual server somewhere, and then you just run your container on that server. So this is like the easiest way to host an API. But you also have, like on AWS, you have a service called SageMaker. So SageMaker allows you to also build APIs around your model. They have their own structure, like the code needs to be in a certain structure. But what is good about it is that it takes like you don't need to use Fast API. You don't need to do so many things. Like SageMaker takes care of a lot of the steps for you. So that's like for AWS. For GCP, you also have this. You can say similar options. You can either host it on a like cloud, what's it called, compute engine, which is like the EC2 instance equivalent in GCP. So like you rent a server and you deploy the API on it, or they have also in GCP, they have like a service called Vertex AI, which has something similar to SageMaker, where you can containerize your code and then run it in a way that's Like you don't specifically have you don't have the server that you rented and you access it and then you do all of those things. Vertex AI takes care of all of that. You just give it the configuration, like I want this type of machine, I want this amount of memory, things like that, and it takes care of it. So
That's
this is
great.
like for cloud deployment. Yeah.
This is super. Tell me one thing, one final question before we move on to the next, because this is the main chunk, I think, what we discussed. So you said that you, if the data is not good, then you do not move into the second building stage, right? Building the algorithm stage. So
Yes.
do you also do, because I think this is an important question for your clients who will be watching this video and asking you, so why don't you help them in unsupervised annotation and ask them to annotate it and make it faster, and you can also, you know, you can use
What do you mean by what do you mean? Can you
so you can
explain
use
that?
segment anything to help the,
Okay, okay, I see. Yeah, I mean, look, it's not like we don't offer them anything. It's just that we say we can't move to the next stage like this. This is what we said. But like after that, there could be several ways to go about. Like if the data is good, like the DICOMs, the scans are good, but the annotation is bad, then it becomes also a question, how bad is it? Is it very bad where you can't do anything, or is it you just need some touch-ups, you just need some corrections? So then we can, what we can do is we can either have a team of annotators that works with us on those cases, so we correct them or we annotate them from scratch, or we work with a third-party company that does the annotation. So we tell them, okay, this annotation is not good, but you can do the annotation with this company, and we have like we have a partnership with basically this company and this client, and we also supervise what this third-party company is doing. We've done this before. I'm not just mentioning it, because even when you work with third-party companies, you still have to validate the data. You still have to, when they send it to you, you have to go through it, see, and usually it takes like 2, maybe 3 different iterations to get everything done very good. So we also do this, and we also, what we usually tell the client is also, it's not exactly what you said, but it's something similar, which is like model-led annotation. What we tell them is that, look, instead of doing 1,000 scan, annotating 1,000 scan, let's start with 50, which is annotated properly. Let's build a model on this 50.
train
And
it
then
and
what
make
we do, yeah, we use the model to run the scans on the, using the model. And then the output of the scan is corrected by an annotator. So instead of,
it perfect. Perfect. Yeah.
yeah, so instead of the annotator doing everything from scratch, they're going to start from something and then they just correct it. And then we can do this at different stages. So we can do this as 50 scans, 100 scans, 200 scans going forward. So that's also something that that we provide. Yeah.
Yeah. For me personally, for brain scanning, I can really get a good estimate from KNN, just simple KNN, unsupervised. And it
Hmm.
gives them good, and then I do some touch up, send it to the medical person, they
Yeah.
make it better. And yeah,
Yeah.
so this is fun. Okay. Okay, that's great. Okay, so let's go on to the next question, Noor.
Sure.
So yeah, this is an important, domain adaptation. So did you work with different hospitals or different scanners from the same person and it didn't work out? Or, you know, just like from experience point of view, not like theoretically. Do you have such
Yeah.
cases?
Yeah. So I noticed a couple of things. For example, with one client that we've been working with for like 3 years now as contractors, then he became a client of PyCAD. They had to get a lot of data from different hospitals, different scanners, because the product was going through FDA process. So it had to be generalizable to a certain extent. So this, of course, you get to a point where you need to have connections with different hospitals. You need to network, because not everyone is ready to give you their data, and you have to assure them that you're gonna anonymize the data. So all of these things. Now, To be completely transparent with this specific client, we mostly did, they were taking care of this part. What we did was we take the data and then we either build the models or we deploy them. But I did notice that, okay, the models were getting better. The more data we have, the more variable the data is. And this, for one of the products that we helped build for this client, they did go through FDA process and they did get the FDA approval. So it shows you that, okay, it's important to have this generalization. It's important to have this like variation in your data set, but it's not always necessary. If you're going to go through FDA or CE in Europe, then this is, I would say, is necessary. You have to go through this process. You have to network, get data from different hospitals, different clinics, and build your models using this data. But some of the clients who come to us, they have very specific use case on their own data sets. They're like a small company that works with specific hospitals, and they just want something to work with those specific hospitals. So in this case, even data from those hospitals will be more than enough to build a model. And we can also think of this as like a gradual process. You don't have to get data from all hospitals in the world to build your first model. You can build your first model for the first hospital that you're working with. If you get a new client, different hospital, here I'm talking about like our clients' customers. Like our client is a startup, their customers are hospitals. If they're working with one hospital in the beginning, they should get data from that hospital. We build a model, we test it, and we should make sure that it works well for that hospital. If they go to a second hospital, we test the model. If it performs well, that's great. And it's bound to perform less well, because if they might have some other scanners, even the radiologist, how do they do the process of doing the MRI, or all of these things can change. In that case, take the data from that hospital, retrain the model, make it better, and you can continue doing this. So it's I think this is the core of machine learning. It's an iterative process. It's not you do it once and you forget it.
Yeah, so what I wanted to ask is that you use an MRI or CT from one scanner and test it on another scanner, and it didn't work well. So it happened, you said, right?
Yes. Yeah, it could happen. Look, it's even the same scanner, but different populations. Maybe it's not going to work well. I see. It's I would say we have to test it before we can give like an exact answer, because you can't know. The reason why, like, maybe if you had asked me this question a year ago or so, I would have said, you always need this. You always need the models always need to be the data always needs to be coming from different providers. But the reality is, I noticed that, for example, one of the extensions found on 3D Slicer is called Dental Segmentator. They have an NNUNet model behind the scene working. So it's open source, so people can go look it up. They have their GitHub repo for the segmentation for the AI model, and they also they didn't share the data, but they shared information about the data. So the model was trained on, I think, 455 scans, less than 460. This for sure, 460 CBCT scans. And I believe it's one or two hospitals, because it's the dentists from that hospital were the ones behind building this model. So I don't think they were like many hospitals. But what we notice is that several people who are using this extension are saying it works very well. And we tested it also on some other data. Of course, it didn't come from that hospital. And it works very well. And I was very surprised. But and not just that, I've seen people who have built like tools where they need the segmentation first, So they would go to 3D Slicer to use this extension, get the segmentation, then port it or import it to their software to continue working on it. And I've seen them share several posts where it actually the segmentation works very well. So it shows you that even a small set of data points, but I'm sure they did a really, really good job for in the annotation. I'm 100% sure they spent a good amount of time doing the annotation. If you just do this, you can already have something that works really, really well. So then of course it's gonna become if I make it 1,000 scans, then how much better can my model become? And then 2,000 scans, so on and so forth. But it's this also surprised me, to be honest, because if you had asked me how do you think a model like this would perform on unseen data from other clinics, I would say most likely it's not going to work very well. But it just does. But I think like the two reasons or core reasons behind it, at least that's what I believe, is the data has been properly annotated, and the use of NNUnet, which is like it's a library in itself. It's using PyTorch behind the scenes, but they do some, like before the training starts, they do like neural network search, and they find a really good architecture for your specific data set, so the models are also performing well
What
because
is
of
the name
that.
of this repo?
It's called NNUnet.
Oh, okay, okay, okay.
Yeah.
In any unit, it searches among the architectures.
It looks at your data and then builds an architecture that is specifically designed for your data set.
Okay,
So yeah.
okay. So I have two more questions regarding this. So when you are doing the training, so you do it in the cloud or do it in your own GPU?
Most look, we lately my brother bought like a more or less a good machine. It has I forgot the type of the NVIDIA GPU, but it has 16 GB of GPU RAM, which is good for lots of models. But a lot of the training we do it on the cloud.
Okay.
We have
So
to
how
do
do
it
you
on the
make
cloud.
sure, like, how do you make sure that, so what is the process to make sure you don't overuse it? Like, how to make
You don't
sure that,
you don't
uh,
overuse what?
so you have to do a hyperparameter tuning in all these things, right? So you do it in one go, like using like um, different hyperparameter tuning packages, or how do you do it in optimized way? How many takes you have to take in the cloud?
Yeah, sure. Look, for what we realized before, we used to, because now we're using NNUnet a lot for lots of segmentation tasks. We use NNUnet. NNUnet already, as I said, it before the training starts, it looks at the data, it builds an architecture that works very well on your data. So when doing this, we mostly, like, you can do it once and you already get really good results. Before that, when we were building our own models like Mascar CNN, and you have to basically do hyperparameter tuning, then of course you would either like define a grid or something like that for different parameters, and then run the models, run the training several times. Now, in the case of first of all, for startups that we've worked with, most of them, they give us access to their own servers. So like we have 24/7 access to the server, and we can run several trainings at the same time. We can do all of those things. And it's also, maybe some people do not know this, but AWS, GCP, Azure, they all offer a lot of cloud credits for startups in the beginning. Like they I think they offer you up to 200K US dollars of cloud credits. So we had lots of credits to experiment, to test, to do all of those things. And it's only available for I think a period of 1 year. So like you are incentivized to use as much resources as you can. Yeah, so I don't know if I answered your question,
Yeah,
but that's,
you answered
yeah.
my question. So I wanted to know whether you like, if you do it on cloud, you had one question is that how to minimize the credits, like right? So you said that you have access to those, and your brother
Yeah,
has Muhammad has recently bought a GPU, so it answered the
yeah.
question.
Yeah, for right now with my brother's machine, we're doing so many trainings, but I still train models on the cloud because sometimes I just want like a machine with 80 GB of GPU RAM. So that's you can go much quicker. So, but the thing is, most people go to AWS, GCP, Azure because these are the known ones. But there are so many smaller companies that are unknown to a lot of people, but they have really good machines, much cheaper uh, costs. So I'll give two examples that I've personally tested. There is Vast AI, and then there is Rumpod. These two companies, I personally I do prefer Rumpod. I'm not affiliated with them in any way, so I prefer Rumpod. Vast AI, I noticed issues with their machines, but both of them have cheap machines, and like you can train really good models, and it's not gonna break the bank. It's gonna be a few dozen dollars or so. It's not gonna be much. Yeah.
That's great. Superb. Thank you. Next
No
question.
problem.
I'm
Yeah.
learning a lot from you. Okay, so I have already talked about it, but how do you make sure that you know regulatory compliance, FDRC is there, or how to bypass that for upcoming startups like you? Uh,
Yeah. First of all, people should know that FDA and CE are required when you're going to do diagnostic AI. If you're not going
what
to do diagnostic AI, so
diagnostic?
when yeah, so like if your AI is going to make decisions and the doctor will take those decisions blindly, like if like the AI would tell him, okay, there's a tumor here, and the doctor would just go with it. For these kinds of softwares, you need to get FDA or CE approval. It's a must. If you're not going to do that, like there's so many. This was also something that surprised me because before I thought that if you're working if you're building AI for the medical field, then you need to do these like your software needs to be FDA or CE approved. But reality is not. Some softwares that do not directly do diagnostic AI, but they assist maybe the doctor, and the doctor has to take responsibility at the end to say like there's a tumor, there's no tumor. Tumor is not a good example, but I give you a better example. A better example would be, imagine you have a software AI software that does segmentation of the bones, maybe in your on your arm or on your legs, and it segments the bones, and then the doctor might do 3D print, might 3D print those segmentations, and then he would use them when he's trying to figure out how he's going to do surgery, something like that. So the AI or the software did not tell you, it did not give you like direct recommendation on what you should do for the surgery. It didn't do that. It gave you the possibility to 3D print those parts, and then the doctor will look at them. He might even look at the 3D meshes on his screen and maybe do some measurements, and then the decision will be his at the end. So in this case, there is a possibility that you don't even need FDA.
So let me
And
rephrase the yeah.
yeah,
Let me
go ahead.
rephrase the question. I think more than FD, I think I use a wrong term, but it's about data uses, unidentified data. How do you make sure, like, let's say when you take a data set from a person, how do you make sure that the patients are given consent to the corresponding? Yeah.
Okay, I think that's a different question. So
Oh,
uh,
sorry. I
yeah,
just
because
yeah.
yeah, FDA and CE means you have the product and you're going to give it to clinicians, hospitals, something, and they're
Okay,
gonna
sorry.
use, yeah.
Sorry, I
So that's where you
misunderstood.
need. But if we're talking about data and how do you make sure that the data does, like there are rules that you need to follow. most of these rules do not fall on us directly, like PYCAD, the agency. It falls on the client himself. The client, because the client is the one who's getting the data from his customers, like
Hmm.
hospitals, clinics. So he agrees with them on how are they going to handle all of that. And I mentioned before, like with the company that we were working with, about they have to make sure that the data is anonymized. Like I think we even, if I'm not mistaken, I think my brother built an anonymization tool for them so that whenever they get the data, they anonymize it. So they're like remove the patient name, anything that could point to the patient, at least in the metadata, not in the pixel or the voxel data. So they agree, like our client would agree with the providers that he's working with. Okay, you give us data, this is how we're gonna anonymize it, and then when we get the data after that, so it's anonymized, and then we build something on it. If the client comes to us and they have no data, then we tell them we have, like, there are two solutions. Either you buy the data, and we have some partners that provide this, like just put them in contact. Okay, this guy can find the data. You just tell them what kind of data, what kind of modalities, which population, all of that, and they're gonna find out where to get that data. Uh, or I would tell them, if you're just building MVP, for example, some companies come to us just for an MVP. They are really at the early stage. They just want to build something, show to investors, maybe raise some funds. In that case, we tell them, okay, maybe we can just use some open data sets. You have the cancer imaging archive website, which has a
Hmm.
ton of data, like really a ton of data. Some of them are restricted, but I think most of them, or a lot at least, are not restricted. Like you can just download them, you can build something on that data, and you have so many other researchers who are providing their data. When they open source their models, or where they open source their research, they also share the data. So you can also go that direction. Like you take some open data set, build a model, build an MVP using that model, and then move from there. Because that could also open doors. Like if you go to a hospital with the MVP in your hand and you
Hmm.
tell them, look what you can do with my software, I think this gonna make them much more open to maybe giving you their data, and maybe signing something with you so that you can continuously get data from them, things like that. Yeah.
That's great. Okay. Um, I think we should move on to the next person. I'm just thinking about the information that you're giving me. It's so deep. Thank you.
No
Um,
problem. I hope it's it's useful. Yeah.
and not only me, I'm sure it will be helping others too. So yeah, startup experience and industry impact. So I would say, um, how do you see, before I start? How do you see? Because also our time is limited. We have to, probably we can do another more podcast, let's say in the next month with you, uh, if there is, we have time bandwidth with each other. So
Sure.
how do you think, like, what is the difference between research? I don't want to rush through it, so let's just focus on meaningful
Yeah.
questions. What is the difference between the research and PyCAD? Like, what is the difference? What you see, like doing research and building, solving at PyCAD? How do you think the difference is?
Yeah, there are lots of differences. First of all, research usually is a much longer term process. Like you have a PhD student who would spend 3, 4, 5 years doing research on a specific use case. Uh, what we do is basically first of all, we start where they finish, and we also have to go much quicker about it, because
Hmm.
our service is about how do you take a research project and then take it to a step where it could be commercialized, or at least take it in that direction. So um, what we like, I think I posted this one time on LinkedIn. I said one of the qualities or the skills that is required right now in the AI, or in the AI era, which is like not many people talk about it. It's just how do you take a GitHub repo of a researcher and turn it into like a product? Yeah. How do you do this? How do you, because the researcher, if you look at their repos, you have a ton of code that you don't need. You have uh, they they built it for research. They have like these metrics to show, okay, you can do this, you can do that. You have so many things they built because the purpose was the research. But if you're going to commercialize it, or to make a product out of that, then first of all, you can strip so many different things from it. And then you have other things to worry about, like you have deployment to worry about. For example, how do you make this, how do you host this model in such a way that people can actually use it? Because not everyone are going to go to the GitHub repo. For example, a clinician is not going to go to a GitHub repo, clone it, to install the dependencies and run it locally. It's not going to do that. Like even when you make it so much simpler for them, like NNUnet, for example, they have tried to make their library very simple so that even clinicians can use it. Some clinicians do. I mentioned dental segmentator. I think there were clinicians who have some minimum coding skills. They were able to build some model, but most of them will not do that. So like you can't expect clinicians to use code like that. So that's where people like us come into place, like how, or startups come to fill this gap, and then we help these startups. The startups want to take the research and they want to put it in a nice looking product so that clinicians can use it. So I would say it's different challenges, different timelines, and even like different end user. If for us, if we're building something, the end user will be some clinician who's gonna use the product. For them, the end user maybe is just another researcher, so that he can replicate the same work, and then they can compare their work with them. So there are several differences between the two. Yeah.
Interesting. So I really like this idea how you said that you have to turn, like there's so much gibberish in a GitHub repo that you do not need in a deployment. So the deployment thing that you said is just like that, right? You have to build an API, host it somewhere.
Yeah.
So for the clients, you build individual apps for them, like Docker files for them. Like how yeah. So how do you
Yeah.
do it? So that the
Mostly,
clients understand after watching this video that what they will get. Like yeah.
yeah. So it depends. It changes from one client to the other. Docker containers are present in almost all of our work. It's just because you can host like an app inside a container, and also the API inside a container. And what is good about this is that it's very easy to move from one setup to the other if you have containers. So I give you one of the latest examples that we were working with one of our clients. So he said, okay, I want you to build me API that I can integrate with my software, and he specified like he wants this AI model to be integrated. So we create the API, containerize it, like create a Docker image, run a container. And then when we started testing the model on different configurations, different EC2 instances, we noticed that for some of the scans, because he had like these very, very big scans, like 1,500 slices in one scan. Some of them were even more than that. Like one of them was 2,000, I think, and 400 and something slices. It's like a whole body CT scan. And when we started to test it, we realized, okay, it's the model that we were using required so much more memory, specifically the RAM, and also the virtual CPUs. So we started to just upgrade the instance. But because we had like containers, the only thing we needed to do is spin up a new instance, and just with 2 lines, you run them in the command line. You have your container, your API is ready. So you have this kind of flexibility when you build things with containers. So yeah,
So
that's
you send these Docker files, like how do they use? What do they get? Yeah.
yeah. So As I said, for this specific use case, we built the API so you can just call it and it returns back to you the response, just like ChatGPT APIs. If you go to the developer section on ChatGPT website, you're gonna see they offer you a code where you can call the models and get a response, and you can integrate that into your product. So this is what we do for the AI part. But there are so many other parts that I didn't talk about them in this podcast. But for example, many of our clients request a DICOM viewer, so a way to load the DICOM, look at the MPR view, so axial, sagittal, coronal, and then maybe look at like a fourth quadrant would be for volume rendering or for the output of the segmentation model, things like that. So what we do is we build the DICOM viewer separately, and then we build an API for the AI model, and then the DICOM viewer can call that API behind the scenes.
This is
And then
not present in ITK. ITK just
so
have those viewers, but they cannot integrate AI.
they can't. No, as far as I know, ITK Snap you can't. You can do some of the AI models. Actually, for 3D Slicer, you can integrate almost anything.
But 3 slicer
But
is very slow.
sorry.
3 slicer isn't it very slow?
It's slow. I was going to mention that it's because you run it on your machine, and most people do not have very good machines. But if we're talking with a client, then we're going to explain to them, look, if you want this AI model, these are the configurations that you need so that you can run it properly. Now it depends on you. You can either buy some really good server with some really good GPU, and we give them like some of the specs. Or if you want to go the cloud route, we can also host it on the cloud. So it's up to the client to decide.
So what they
And
want is it.
yeah, and we've had experience with both. I talked to people who want to host directly on the cloud, and I talked to other people who said no, we want it locally, and we're ready to buy a server. Just tell me the specs. What do I need? And we just tell them, okay, you need this, and then we install it. Like we put things on their infrastructure. Like the simplest way would be to just access the server that they give us, that they have locally. Like if it's Windows, we can even use like something like TeamViewer or so, and we access their computer, and we just install everything. But what we try to do from our side is compact everything and modularize it so that it's quicker. When we get to the
Got it.
deployment, it's much quicker. Yeah, so
Perfect.
that's how we do.
This is extremely good. I love the discussion. I think we should do another podcast when we have time. And in that, should be discussing about your startup experience in industry. I think we have already done it. Or most of it, we can just go through it once again in a different way. After 1 month,
Okay.
we will probably have a different mindset.
Okay,
Um,
sure.
and yeah, so also we need to discover the future, like what you think is coming, because I now see you posting a few bit about LLM and
True.
VLMs. Okay, because I
True.
saw your post. See, I regularly follow you and Mohammed and all the posts on PyCAD. I'm a big fan.
Thank you.
So
Thank you.
I saw that you have a patient's what is said. Uh, what does the doctor write to the patient?
Like a note, medical note.
Yeah, medical note, and you use VLMs to get the data, right? I think you
Yeah,
have a
yeah,
recent post on that. So
yeah,
you're
yeah. True,
explaining
true,
VLMs and stuff like that.
true.
And I'm seeing you talking about DeepSeek. I have seen you talking about AI agents on LinkedIn, right?
Yeah,
There's
true.
something. So I really want to explore the idea of vision agent, because there is nothing called vision agent as of now except one company. So I want to talk about how vision agents can be incorporated into the work style, how you're planning to incorporate it, and all these questions I have to discuss with you. Like all this today, I think the most of the discussion was about your journey and what you did. The next part will be what you are planning, a bit of your journey, continuing from that, and what you are planning in the future, what is coming up, what do what you're learning new. So this will be, and also we'll be talking about um, how how the future of how the clinicians and engineers should work on this to make this feel
Mm,
better. Okay, I think I really wish and hope that PyCAD becomes large, and is one of the
Okay.
first
Yeah.
companies that do consultancy for medical imaging and more medical AI. I'm sure more startups will be coming up like this soon. Okay, that's natural. You're in early game. That's really good, really early. So that's really good. So how do clinicians think and tune themselves? For example, as I understand, clinicians should be given the Docker files and not they should not download the repo and do it themselves, right? Uh,
Yeah. No,
um,
the clinicians should not even get the Docker files. We should like they should just be able to interface with some software that has buttons and stuff like that.
yeah, yeah,
That's
yeah,
what I would
exactly.
say.
So how do they think? And also, how I think in Europe and US, as I see, there are more doctors trying to integrate AI into their workflow. But how do you tell the other countries out there, to other people out, doctors out there, to start engaging themselves in that? What is the
Mhm.
process, and also how to learn? And also, I will discuss about this, but this is important. Like the main idea is that how do you how do you want people to reach out to you over LinkedIn? What are the things that you and your brother do regularly? What do you think? What do you want to say, not think?
Yeah, yeah. So again, thanks for having me on this podcast. I enjoyed having this conversation. Uh, I would say mostly people can find me on LinkedIn. The name is Noor Islam, Nour space Islam Islam, and then Mokhtari Mokhtari.
Yeah, the same
I
as this.
post. Yeah, yeah, exactly. No, it's outside. So that's you're gonna find me on LinkedIn posting a lot about the medical AI stuff. And if you want to maybe get even like a condensed version of what I say on LinkedIn, then you can also subscribe to our newsletter. We have a newsletter called newsletter.pycad. So PyCAD, just like it's written here, so PYCAD.co. You're gonna see already some previous blog posts. Like we've been doing this for 2 years maybe now, so you can see some other samples. And if you like them, I hope you subscribe.
Perfect. Thank you so much. It was such an insightful discussion, Noor.
Thank you. Thank you. Appreciate it.
I'm hoping to have you again here and discuss more. I think before the next episode with you, I will do another episode with your brother, Mohammed.
Mhm.
Probably it will also go for 2 hours. So I will break it up into two pieces. But I hope you enjoyed the discussion. I hope
I
I
did.
had to put the proper intellectual curiosity and ask questions to you that
No,
you
I appreciate it. I really liked the conversation. Thanks for having me.
perfect. Thank you so much, Noor, and I will see you again soon. Bye bye.
Thank you. Bye bye.